In this next topic, we're going to look at individual choice and game theory. I like combining these two topics because if we kind of step back and do a big picture, these help explain where the demand curve comes from, right? The game theory has a little bit broader applications, but it's one the way that we can think about it. So we're going to be thinking about decision making, right? So we've talked about decisions a lot in this class in terms of costs and benefits, rational decisions. We can think about taking a vacation to Hawaii or Alaska, or maybe on your next spring break, you might want to stay somewhere more local, like Alger, just right around the corner from ONU, right? And so you can consider these different alternatives. Each of them have benefits, each of them have costs, and you could think about, for each of you, you may come up with a different decision in terms of the way that you value the benefits or the cost, right? So what we're going to look at in this first section is a way to think about different decision making. Again, you're not actually going to do this in terms of your everyday life and the way that you make decisions, but rather it's just a useful framework for thinking about how we could analyze a decision. We start with our concept of utility. So this is just a pretty traditional, straightforward intro microeconomics class. And so I'm not going to go too deep into the concept of utility. We can just say that for our purposes, it's a measure of happiness or satisfaction, right? In philosophy or in more advanced forms of economic thought and history courses, we might dive a little bit deeper into what utility represents. But for our purposes here, we can just think of it conceptually as a way to measure how happy you are or how satisfied you are with something. We can posit a utility function, which is simply a function that tells how happy you are for a given level of consumption. And so I've got a little U for utility. I've got a little function here. Notice that my utility function has two inputs, right? There are two things that cause happiness. There are two things that determine my level of satisfaction: slices of pizza and apples. So the way that I could write this, right, is 3 slices of pizza, 1 apple. Think for a second, right, if you had to do a scale of 1 to 100, 0 to 100, just how happy would you be if you had 3 slices of pizza and 1 apple? That level of happiness is your utility, right? So utility is just simply your level of happiness. A useful concept for us is going to be marginal utility. And again, when you see the word marginal, what is the word that should be jumping to your head? So we can define marginal utility as the change in total utility for an increase in one of our goods, right? So I've got, again, following the notation where the first input is slices of pizza and the second input is apples, let's think about what this notation is representing, right? So here we go. Here we have this first term is the utility from having 2 slices of pizza and 1 apple. We're subtracting from that the utility from having 1 slice of pizza and 1 apple. What we're saying is, right, we've got the same amount of apples, but now what is the difference in our happiness going from 1 to 2 slices of pizza? Marginal utility simply tells us the additional utility or the additional happiness. And specifically, this is how much happier a second piece of pizza would make us. So again, right, we can think about conceptually, think about on a scale from this is the most unhappy, unsatisfying situation you could have in your life, and this being the maximum amount of happiness that you have. Think about where you would be if you had 1 slice of pizza and 1 apple. For me, I'd be about right there, right? It's not bad, it's not great, right? But if I were to get a second piece of pizza, my happiness would probably go up right here. The change in my utility, the difference in my levels of utility, how much my utility increased by, is what I'd call my marginal utility. And specifically, it's the marginal utility of my second piece of pizza. We've got to the right a little graph of slices of pizza against utility, and for pizza, for most people, and for many, many goods, utility is going to follow this kind of pattern where how would you describe in your own words what this pattern of utility looks like, right? Where it looks like this pattern is that our very first piece of pizza has this huge increase in our utility, right? And think about that, right? You're hungry, you don't have any pizza whatsoever. How good and tasty is that very first piece of pizza, or that very first time that you see a movie, right? With many things, we have a very, very large marginal utility for the very first unit. And as we have more and more pizza or more and more consumption of many things, right, we get happier. Our utility increases, our satisfaction is going up, but the change in our utility is getting smaller and smaller and smaller, and it's kind of tapering off. And for some things, right, we can even think about when our marginal utility might go negative, when our total satisfaction could actually start going down from having too much of something, right? So that's a general pattern that we see with not just with pizza, but with many different items. And so we have a specific name for that pattern in the utility function. We refer to it as the diminishing marginal utility, right? So if you recall, marginal utility is the change in our utility divided by the change in whatever it is we're looking at. In this case, it was slices of pizza. Notice that this equation for marginal utility, change in u over change in x, for this utility function over here on the right, utility is what we were measuring vertically, and we were measuring slices of pizza horizontally. Marginal utility is the slope of the overall utility function. Marginal utility is the slope of the utility function. And what we have with that slope is that slope diminishes. Notice that the slope starts out very, very positive, and then as we move to the right, as we have more and more slices of pizza, the slope stays positive, but becomes a smaller and smaller number. It diminishes, and it's possible for it even to go negative, right? And so we could think about some of the movies that you've watched multiple times in your life, right? This Batman movie and some of those superhero movies are ones that people tend to watch over and over again. But you can think about, right, do those movies exhibit diminished marginal utility? Is there diminished marginal utility for reading or doing other activities? Is there, question that I want you to respond specifically to, can you explain why there might be a diminishing marginal utility to exercising? Is that something you've experienced before? The next thing that we want to do is we want to consider, now that we've got our utility, which is half of the story, we want to consider, if we know what utility is, how can a consumer make the best choice about consumption? And so to prompt this, I'm going to leave this wide open. Let's assume that we have an individual, and let's assume that that individual, the goal of that individual is to maximize their own utility. They're trying to maximize their total utility by spending $12. They've got $12 in their pocket, and they can spend that $12 on one of two things, right? They can either buy pizza or apples. Pizza, if they buy a slice of pizza, are $4 per slice, whereas an apple is $2 per apple, right? Those numbers are unrealistic, but a little bit easy mathematically to work with. So we've got the cost. Now we want to think about the marginal utility. Notice that this column is not total utility, but it's marginal utility. So this is how much additional utility you get for the first, second, third, fourth, fifth slice of pizza. Step back and notice, for this individual, they've got pizza, they've got apples. Which of those do they like more? Right? So think about which of the pizza and apple, which of them they like more. And then the follow-up question that I want to try to have you tackle before we go into the formal method is, so what should this person do? What should this person with $12 in their pocket that can buy pizza or apples, what should they do? Meaning, how many slices of pizza and how many apples should they buy if their goal is to maximize their utility? And here we go. With looking at, from an economic perspective, how would rationally we choose the amount of slices of pizza and apples in order to maximize utility? We have this thing in economics called the rational decision rule. And I say in quotes, this is what we have, because unfortunately, this doesn't have a common name across textbooks, right? There's no consensus on the terminology that we use, but this, we see it many, many different places. And I think that this is one of the most important concepts in economics, and it's unfortunately we don't have an agreement on what the basic name for it is, right? But in general, what we're doing is, this is in a sense a form of cost-benefit analysis, right? We're looking at the benefits and we're looking at the cost. Marginal utility is the additional satisfaction, right? That's the benefit that we get. The marginal utility lists out the benefit that we get from having one more slice of pizza or one more apple, whereas the price is representative of the cost, right? We're assuming that there are no other economic costs that are involved in this decision. Then what do you have to give up to get a slice of pizza or an apple? The money you have to pay, the price. The price represents the cost, right? So what we want to do is we want to calculate the benefits compared to the costs, right? Clearly, if we just glance at these numbers, everybody likes pizza a whole lot more than apples. But pizza is also more expensive than apples. If we go back, everybody likes Hawaii or Alaska over, not everybody, but many people are going to like Alaska or Hawaii over staying home for a spring break. But these other kinds of spring break are more expensive, right? And so that's what we're getting at here is how do we compare the benefits with the costs? So the way that we do this calculation is we calculate this, and this is what the Colander book calls the rational choice decision rule. It calculates the marginal utility of a good divided by the price of a good. And if you've got multiple things that you could consume, if you've got multiple alternatives, if you calculate the marginal utility divided by price for two different sets of goods, whichever has the highest marginal utility divided by price is the thing that you should consume extra of until all of your money is spent out. You just follow that rule of calculating marginal utility per price, and that will get you to the optimal level of consumption. So we can think about, right, for that very first slice of pizza, the marginal utility for that first slice of pizza is 40. Gosh, what are the units? On utility, we refer to a unit of utility as a util, right? It's a little bit of a ridiculous term, but that's 40 utils, 40 units of happiness, 40 units of utility, 40 units of satisfaction. A slice of pizza is way more satisfying than your first apple, but apples cost less. So we do this calculation, right? The marginal utility of a slice of pizza divided by the price of a slice of pizza, 40 divided by 4 equals 10, and I compare that number to, for an apple, the marginal utility of the first apple divided by the price of that first apple, $2, and if I compare these numbers, the rational decision rule says whichever is higher is what I should consume. So this is saying I should first buy this first slice of pizza. Back up for a second, right? Think about what are the units involved in this. 40 over 4. What am I measuring in my numerator? What am I measuring in my denominator? And what are the units of this calculation? All right, so we've got 40 in my numerator. 40 was the marginal utility, and the units on marginal utility, that's 40 units of happiness. And then what was in my denominator? 4. Where did the 4 come from? It was $4, right? We're going to do the simple version, not the more complex long version of the absolute price, and we'll just say, yep, it's $4 is what we're measuring. So what do we have? We've got this value of 10. That's 10 units of happiness, utils, per dollar we had to spend. We spent $4, but with that $4 of that first piece of pizza, we got 40 units of happiness. That was 10 units of happiness per dollar we had to spend. Whereas for the apple, it's 3.5 units of happiness per dollar we had to spend. What's a better bang for the buck, right? I often like thinking about this as the bang for the buck calculation. But again, that's not an economic term, but it's a useful way to think about this, right? We're taking our benefits and dividing by our costs. We're getting a measure of our unit per benefit per dollar we had to spend. How much happiness we get per dollar we had to spend. What's a better way to use your money? Clearly, it's better to use your money first buying this first slice of pizza. How much money did we have to spend, right? So we had $12 to spend. After we buy that first piece of pizza, can we afford to buy more? Sure we can, right? $12 minus the $4 we spent on the first piece of pizza, we've got $8 left to spend. We could buy either a second piece of pizza or our first apple. And again, if we look at the bang for the buck, the marginal utility per dollar we had to spend, what's a better way to spend my second little bit of money? Second piece of pizza, right? It's not quite as big of a bang for the buck, right? I only get 20 units of additional happiness, but still, for the price I'm paying, it's definitely worth it. I should spend my next bit of money on a second piece of pizza, right? Do I have money left to spend? Yep, I had 8. I bought $4 worth of pizza for my second piece of pizza. I've got $4 left. So here's the big picture, right? I can either spend my last $4 on a piece of pizza, or I could spend my last $4 on buying these first 2 apples, right? That third piece of pizza is way better than my first apple. Way better is maybe a little bit extreme. It's better, I get more benefit, but it's also more expensive. When I do my per unit calculation, right, both the first and the second apple, both of those have a better bang for the buck than my third slice of pizza. So even though I like my third slice of pizza more than my apple, I should spend my last $4 buying these first 2 apples, right? So we've got, to answer the original question, hopefully this matches up with what your gut told you. What's the best way to spend $12? It's by buying 2 slices of pizza and 2 apples, because it maximizes total utility. Real quick, right? Can you calculate up what is the total utility? We just talked through marginal utility, but what's the value of total utility for this combination of pizza and apples? We are going to look at 2 basic variations on that model that we just talked through, right? So we've got what if, let's consider a hypothetical, what if the price of pizza increases to $8 a slice? So what if the price of pizza goes from $4 up to $8? Notice what changes in this model and what doesn't. Notice when the price of pizza goes up, what happens to the marginal utility of pizza? Think about whether or not that's a realistic assumption to have the price change have no impact on marginal utility. However, the calculation in this next column of marginal utility per dollar spent, that is going to change, right? The denominator is the price, and if the price goes from 4 to 8, if the price doubles, what's going to happen to the bang for the buck? It got a lot smaller. So again, we can think about, if we start out with $12, can we afford a slice of pizza and an apple? Sure, we could. Let's think about where's the best way to spend that first dollar. The marginal utility per dollar spent of apples haven't changed, but the marginal utility for a price of pizza, that first piece of pizza, did get smaller. Still, though, it's a better way to spend our first dollar of money in our pocket. So we'd still want to buy 1 slice of pizza, but do we have any money left? Well, we've got $4 left in our pocket, but let's also consider the possibility that you might have a credit card, right? So maybe you might be able to do some debt financing. Let's assume that you could borrow $4 and buy a second piece of pizza. Should you? Think about this though, right? The first apple has a marginal utility of 3.5 units of happiness per dollar. That second piece of pizza, yeah, it makes you happier than that first apple, but it's so expensive now that it's just not worth it. Why don't you go to a vacation in Hawaii? It's a really great vacation, but it's so expensive, it's just not worth it from a cost-benefit perspective, right? So where do we want to spend the remaining money? On that first and that second apple. That's a better way for us to spend our $12. Notice, if we go back and forth between this story and the previous story, in the previous story, we were buying 2 slices of pizza and 2 apples. Now, what happened? When the price of pizza went up, what happened to the amount of pizza we wanted to buy? The amount of pizza, oh geez, I just changed my notation. The amount of pizza that consumers wanted to buy got smaller. You know what this is, right? This is an inverse relationship between prices and quantity demanded. That basic demand curve that we've been drawing for a couple of topics now, right? It showed an inverse relationship between the price people were paying and how much people wanted to buy. When prices went up, the amount that people wanted to buy got lower. That's the point of us looking at this marginal utility model and this rational choice decision rule, is that it is the fundamental concept that underlies a downward sloping demand curve. Awesome. So that's where that comes from. We can add one additional thing, right? And so let's go back to our original story of $4, $2. What if instead we have more income, right? What if now we have $16 of income? If you recall, when we had $12 of income, we wanted to buy 2 slices of pizza and 2 apples. Now, what if we have $4 of additional money to spend? If we have $4 of additional money to spend, how should we spend it? Well, we could buy a 3rd apple and a 4th apple, or we could buy a 3rd slice of pizza. What's the better way to spend our money? The bang for the buck tells us it's better for us to buy that 3rd slice of pizza rather than the 3rd or 4th apple. Apples are cheaper, but they just don't bring in enough utility to make it worth it. Notice, what do we have? We've got when the amount of income we had went up, what happened to the amount of pizza we wanted to buy? The amount of pizza we wanted to buy went up. Do you recall what's the name for that kind of scenario? When there's an increase in income and the demand increases, do we refer to those as normal goods or inferior goods? So the story with this rational decision rule and the impact of the substitution when prices changes and income when income goes up is a little bit more complicated than what we're presenting here. But again, this is just an intro level class, and so I think that's a decent place for us to leave it. There's one other thing that we do want to introduce, and again, if you're thinking about going into marketing and you're thinking about consumer behavior, then this might be a little bit more useful to you than some of the other majors, but we'll go through this a little bit quickly. We've got this concept of an indifference curve. What an indifference curve does, we've got a definition. It shows different combinations that yield the same level of happiness, the same level of utility. So notice what I've got in this graph. What am I measuring horizontally? I'm measuring the amount of apples. What am I measuring vertically? I'm measuring the amount of pizza. It's not our traditional price quantity graph. No. We're looking at slices of pizza and apples. We're counting up a quantity on both the vertical and the horizontal axes, right? So an indifference curve is going to have some kind of shape like this. Actually, an indifference curve can have a number of different shapes, but for many goods that have pretty traditional, well-defined diminishing marginal utility, this is going to be the shape of the indifference curve. What does an indifference curve do? It's got a bunch of different points on it, right? And so any of those points on the curve do what? They produce the same level of utility, the same number of happiness. So notice we've got, this is, just to put some hypothetical numbers on it, let's assume that this is 2 slices of pizza and 2 apples, right? And there's a certain amount of utility or happiness that comes along with that. Notice that this utility, I've got it U0 for this is my initial level of happiness, and I've got a bar over it. Do you recall what a bar over a variable represents? Actually, it can represent a number of different things, right? In statistics, it means average. When we're talking about theoretically, usually when we put a bar over a variable, we mean that variable is held constant. So we've got on this line, utility is held constant. It's the same utility at each point. So think about this conceptually. How happy is it going to make you to have 2 slices of pizza and 2 apples? Again, conceptually, if we think about a scale, where are you going to be on that scale if you have 2 slices of pizza and 2 apples? Now, I want to think about, do this thought experiment real quick. What if I took a slice of pizza away from you? If I took a slice of pizza away from you, you're going to lose some of your happiness, right? So the only way that I could maintain your happiness is by giving you some more apples. So a question is, how many apples would I have to give you in order for you to maintain the same level of happiness as what you had before, right? If I take away a slice of pizza, I've got to compensate you by giving you more apples, but what's the amount of apples that it would take to get you back to that same level of happiness? That answer is going to be different for everyone, right? So different people are going to feel differently about apples. If you really like apples, it's probably not going to take that much to get you back to your original level of happiness. If you're just very meh, blah about apples and they don't do a whole lot in terms of creating happiness for you, then that jump in apples might be a lot more significant for you, right? What I'm arguing is that the shape of these indifference curves are formed by individuals' underlying preferences. And again, it looks like there's this inverse relationship because in order to maintain your level of happiness, if I take something away from you, I've got to give you more of the other thing in order to get you back to your original level of happiness. Right? So those are two different points that are on a single indifference curve. But notice I've also got U bar 1. I've got a different level of utility. Does this second level of utility represent higher happiness or lower happiness? Notice it represents having more apples or more pizza. All of those things are going to make you happier. In general, what we can argue is that these indifference curves, different points on one curve, all show the same level of happiness, but these curves that are further from the origin represent higher levels of utility, higher levels of happiness, higher levels of satisfaction. Here we go. Budget constraints. The other piece of this, right, so go back for a second. These indifference curves are really fundamentally talking about the utility, the happiness, the benefit that we get out of consuming pizza or apples. But there's also a cost associated with things. To talk about the cost, we use the concept of a budget constraint. What a budget constraint does is it shows different combinations of goods that can be purchased with a given level of income. So question real quick, if we've got $12 of income, what are all the different ways that you could spend your money on buying apples or slices of pizza? What are all the different ways that you could spend $12 given those prices? When you've listed out all those different ways that you could spend your money, what you came up with was different points on a budget constraint. A budget constraint just simply is a graph that shows all the different ways that you could spend your money, right? So think about this for a second. I'm going to do a little bit of algebra real quick that we can get to the same point as what you just found, right? So if we think about spending money on slices of pizza, right? We got to know the amount of, let's do S for slices of pizza and A for apples. If we want to know S being the amount of pizza, the total amount of money that you spend on pizza is 4 times S. And the total amount of money that you spend on apples is 2 times A, where A measures the amount of apples and 2 is the price of apples. This is the total amount of money that you spend on slices of pizza and apples. But I'm going to hold you to it. I'm going to constrain you that you can only spend $12, right? If you only have $12 to spend, this equation describes all the different ways that you could spend your money on slices of pizza and apples. And think about those values you just came up with. Do they all fit this equation? They should, right? But notice, if we want to convert this version of the budget constraint into an equation that describes this budget constraint line to the left, right, we want, in the form of y equals mx plus b, we want the thing we're measuring horizontally or vertically to be the thing on the left. S, we want to get S alone on the left-hand side. So let's push that to the left-hand side and push the 12 to the other side. So I've got negative 4S equals negative 12 plus 2A. And let's go ahead and divide through by 4. Oh, sorry, not 4, but negative 4, right? Negative 4. What do we end up with? S is equal to 3 minus 0.5A. That's an equation that describes this line, this budget constraint. It shows all the different combinations of apples and slices of pizza that you could buy with $12. Specifically, this tells you if you've got $12 and you want to buy a certain amount of apples, how many slices of pizza can you buy? And again, verify that all those numbers you just came up with do fit this equation. Now notice, what does the vertical intercept here represent, right? The vertical intercept here represents if you spend all your money on pizza. The horizontal intercept represents if you spend all your money on apples. What else do we have in this equation? We have a slope. Think back to a much earlier topic when we talked about relative prices, right? If you calculate the relative price of apples per unit of pizza, you're going to get this value right here. The budget constraint, the slope of the budget constraint shows the relative price of buying apples or slices of pizza. Notice I've got this budget constraint right here that shows a given amount of money that we're going to have to spend. Sometimes we do an I with a bar over it to represent that we're holding constant the amount of income. Notice I've got a second line here, right? So think about what would that second line represent. The slope of it is the same, so that means relative prices haven't changed. What has changed? If this value is 4 and this value is 8, how would you describe what's going on with this higher budget constraint? Right? And so now we want to bring together this concept of the budget constraint tells us about the costs, the indifference curves tell us about the benefits. What we want to do when we're making good decisions is we want to think about both the benefits and the costs together. And so what I'm going to do is notice I've got two graphs. I've got a couple of different things going on in this graph. I'm never going to ask you to replicate this graph. I just want to talk through it real quick. So make sure that you're thinking about what it represents, but don't worry about having to recreate this monster, right? So we've got two different indifference curves, U bar naught, U bar 1. And I also have one single budget constraint, right? So I'm going to call it my budget constraint. And I'm going to assert that there are two possible bundles of goods that I could buy. Bundle X has a certain amount of pizza and a certain amount of apples, and bundle Y has a certain amount of pizza and a certain amount of apples. And I'm going to ask, which of those is the better way to spend your money, right? The answer to that question is this bundle X is a better way to spend your money. Notice, what do these 2 points have in common? They're both on the same budget constraint, which means both of those bundles spend the same amount of money. They have the same cost associated with them, but do they produce the same amount of happiness, right? So notice that bundle X is on this indifference curve, whereas bundle Y is on this other indifference curve. And the rule is that indifference curves that are further from the origin represent higher levels of happiness. They produce the same cost, but bundle X has a higher benefit, and so it is the better way to spend money. How did we get there? So this is a little bit of calculus that I'm implicitly arguing for this, but look at the slope of these lines, right? So notice that the slope of the budget constraint is held constant. It's always, always, always the slope. I can draw a line that's tangential to represent the slope, and the slope is constant at every point on that budget constraint. But now let's check out the slope of the indifference curves at those bundles. If I look at bundle Y, the inferior bundle, the bundle that's not as good, the slope, a line that's tangential, looks something like that. Those two lines, the green and the purple, they cross, right? There's an intersection, but they are not equal to each other. Whereas at bundle X, at my optimal combination of what I want to purchase, the slope of the indifference curve is equal to the slope of the budget constraint. The slopes are equal at the optimal point of consumption. And again, this is jumping a little bit beyond what we need to do for this class, but I wanted to make sure we introduce this so that later on, if you see this in consumer theory, consumer behavior, or some other places, you can think about maybe applying these models.